Welcome, everyone. Come on in. Thank you all for coming so much. I'm Kevin Vallier. I'm an associate professor of philosophy here at BGSU, and I also direct our program in philosophy, politics, economics, and law. If you're here for our first in-person PPEL speaker series in 2 years. So thanks so much for coming. We were able to run these every semester for many years, and we're so glad to have you that you're here in person. This is part of what we call our PPE speaker series, which is our series in philosophy, politics, and economics, which tries to bring together questions about ethics and value with knowledge of how real institutions actually work. We think that, it's good to understand right from wrong, good from bad, but also to understand how certain principles come together to make good or bad institutional recommendations or reforms. And it's based in the philosophy department, but we have a PPL major and a minor. We have for some years now, and we love the program. So, the philosophy and PPL program welcome you here. Our speaker today is Alex Tabarrok, the Martley J. Madden Chair in Economics at George Mason University, at the Mercatus Center as well. He specializes in patent system reform, the effectiveness of bounty hunters compared to the police, how judicial elections bias judges, and how local poverty rates impact trial decisions by juries. He also examines methods for increasing the supply of human organs for transplant, the regulation of pharmaceuticals by the FDA, and voting systems. And over the last few years, he's become one of the most famous economists working on COVID policy, which is why we had him out today, because a huge part of COVID policy is ethical, and a huge part of it is economic, such as learning how to balance risks. And so we thought we would bring in an expert to help us think about those things. So with the Philosophy and PPL program, let's welcome Alex Tabarrok.
Thank you very much, Kevin. It's an honor to be here. The title of the talk is U.S. Pandemic Policy, Failure, Successes, and Lessons. And I want to begin by acknowledging the tremendous tragedy of the COVID pandemic. There have now been over 900,000 deaths due to COVID. That is more deaths than from World War I, World War II, Korea, Vietnam, Iran, Afghanistan, all of the U.S.'s foreign wars combined. Only the Civil War comes close, and now there have been more deaths in the pandemic than even in the Civil War. It has been a tremendous, tremendous tragedy for the United States as well as for the world. The deaths, of course, are the most consequential feature of the pandemic, but the economic cost has also been absolutely extreme and tremendous. So in just 2 months in 2020, 18 million people lost their jobs. The unemployment rate went from about 3.5% to 15% in just 2 months. By some calculations, Cutler and Summers, they estimate a GDP loss in the range of $7.5 trillion. And once you start including things like the lost education, human capital losses, the possibility of medical losses going far into the future, potential long COVID, things like that, then these costs may be, 16 trillion or more. And of course, this was a worldwide event. Okay, we were talking about losses throughout the world, maybe 16 million deaths so far in the world. One of the most upsetting aspects of the pandemic was that this was not a black swan event. This was an entirely predicted and predictable event. We knew it was going to happen. So scientists were warning about a potential pandemic, and not just in general sort of vague terms, but in very specific terms, even including the type of virus, where it might come from, how it might come. Bats are natural reservoirs of SARS-like coronaviruses, talking about Eastern China. Killer flu pandemic is inevitable. Planning for the inevitable. And it wasn't just a bunch of nerdy scientists, talking to themselves in their nerdy science journals. Okay? Bill Gates, right, gave a talk in 2015, a TED Talk, seen by tens of millions of people, where he said, the next outbreak, we're not ready. CNN, 7 reasons why a global pandemic is inevitable. 7. You only need 1. 7. Major motion picture, right? With Lawrence Fishburne and Gwyneth Paltrow. Millions of people saw this. It's Time magazine, warning. We are not ready for the next pandemic. And yet, despite all of these warnings, it turned out to be true. We weren't ready. We weren't ready. Let me take you back to the very early days, which were extremely consequential, the early days and the early weeks. So on January 9th, the WHO announced that there was a mysterious coronavirus-related outbreak in Wuhan, China. January 20th, pretty fast actually, January 20th, the CDC says 3 U.S. airports will begin screening, we'll come back to that word in a few minutes, will begin screening for coronavirus. January 21st, the CDC confirmed the first U.S. case, right, which was in Washington State near Seattle. And then January 23rd, it's a Thursday, 10 a.m., Wuhan was put under quarantine. Now, Wuhan is a city of 10 to 11 million people. It is a major city in China. And China put the entire city under quarantine. This was by far the largest quarantine in world history. And of course, as we know, it was just beginning. This was when I began to freak out. Because I'm not an epidemiologist, I'm not an infectious disease specialist, but as an economist, I'm trained to look at what people do rather than what they say. And what China was doing was telling me, this is incredibly serious. This is incredibly serious, okay? Because if anything, my thinking was that the Chinese government, an authoritarian government, was probably more concerned about GDP than about human lives relative to other democratic governments in the world. So if China was willing to take this huge hit to the economy by shutting down this major city of 10 to 11 million people, not letting people in, not letting people out, if China was willing to do that, then that told you that they were scared. And if they were scared, we should have been really scared too. On the same day that Wuhan was quarantined, the WHO said the outbreak is not a public health emergency of international concern. They backpedaled, they quickly got the right story a little bit later. January 30th, the WHO issues a PHEIC. February 3rd, the US declares a public health emergency. Now, let's go back to January 20th and start filling in a few things. As I said, the CDC says 3 US airports will begin screening for coronavirus. But screening isn't testing. They don't have a test. They're just taking like temperatures. They're not being tested. Not even the passengers from Wuhan. Moreover, okay, this is from Michael Lewis's book, when local health officers set out to find these possibly infected Americans that the CDC had met at the border and make sure that they were following the orders to quarantine, they discovered that the CDC officials who had met them upon arrival had not bothered to take down their home addresses. Unbelievable. Unbelievable. Now, let's January 21st. Remember, this is the day that the CDC confirms the first U.S. case in Washington State, okay? And it so happens that there's an infectious disease specialist at the University of Washington, Helen Chu, okay? And she has been studying for months flu. She doesn't know about SARS, okay? She doesn't know about SARS-CoV-2. She's just been running a flu study. But she's been collecting all of these swabs, okay, from people in the Seattle, Washington area. She's been collecting these swabs for months. So she says, let's back test them. Let's go back and now test to see if any of these people who were exhibiting flu-like symptoms, maybe they had SARS. Let's go back and test all of the samples. I got them right here. But the CDC and the FDA say no. They forbid her from back testing. And she is freaking out. Okay? She says, look, we got this data. We need to do something. Okay? This is not, a conspiracy. This is the New York Times, right? A lab push for early tests. Federal officials said no. It's the New York Times. Okay? Chu, eventually, to her credit, defies the CDC and the FDA. Okay? So on February 25th, she starts testing. And she immediately finds a new case, a teenager with no connection to China. Okay? She informs local officials who rush to find the teenager, and they stop him just as he's entering his high school. He's sent home to quarantine. So he would think, fantastic. Maybe we've stopped an outbreak. This is great, right? Okay, what does the CDC and the FDA say? Okay. Later that day, it's from the New York Times, the investigators and the Seattle health officials gathered with representatives of the CDC and the FDA to discuss what happened. The message from the federal government was blunt. What they said on the phone call was cease and desist to Helen Chu. Stop testing. Stop testing. That's what the CDC and the FDA are doing. January 30th. So one of the things that the government is doing is evacuating American citizens from Wuhan. And 57 Americans are evacuated to the Omaha National Guard base. It turns out that right next door to the Omaha National Guard base is the National Center for Health Security. This is a world-class center in pandemics, in infectious diseases, and in response. And it's led by Dr. James Lawler. And Lawler wants to test the evacuees. Okay? Now, who is this guy? Is he some, just country bumpkin doctor? Okay? He wants to test the evacuees? No. He's a commander in the U.S. Navy. Okay? He's trained, he's an infectious disease physician. He's trained in pandemic threats. He's responded to multiple infectious disease emergencies like Marburg and Ebola throughout the world. He was the U.S.'s expert on the Ebola. He briefed the Joint Chairman, the Chief of Staff, and so forth. He served under President George W. Bush in the Homeland Security Biodefense Council. He also served under President Obama and helped to coordinate the H1N1 influenza pandemic. So this guy is totally connected, Democrats and Republicans. He is like one of the world's leading experts. He's right there. He wants to test the evacuees. The CDC forbids him from testing. Even though every single one of those 57 Americans wants to be tested. Not allowed. Now, other countries, they're also evacuating their citizens. So the Germans have evacuated citizens from Wuhan, okay? And they test them. And what do the scientists say when they test the evacuees? We discovered that shedding of potentially infectious virus may occur in persons who have no fever and no signs or only minor signs of infection. So right from the very beginning, it's clear that asymptomatic people can infect other people and can shed the virus. Okay? The Germans test, CDC doesn't allow it. 57 Americans are sent home without being tested. Okay? And James Lawler later says there is no way that 57 Americans from Wuhan were not shedding virus. No way. Now, the CDC's primary job, right, is to develop a test. That's their big job. To rapidly produce a SARS-CoV-2 test kit. On January 13th, the WHO had posted a protocol developed by a German firm, okay, to test for SARS-CoV-2. It's used all over the world. The CDC could have used this protocol, but they decide that they're going to design their own test. Okay? In designing their own test, the CDC violates standard laboratory operating procedures, and they contaminate their test, making it useless and setting the United States back many weeks. They contaminate their own test. Weeks of time are lost. Now, look, whenever, the battle begins, the plans go out the window, right? We kind of have to expect errors are going to be made. There's going to be fumbles. But these errors which I've been pointing to, they also illustrate not simply a fumble. What they illustrate is a strategic policy error. A strategic policy error. And that is the CDC never had a plan for widespread testing. They never had a plan for widespread testing. Because the only way that widespread testing was going to happen was if you brought in the big private labs. The public health labs just simply could not. They did not have the capacity to do this on their own. So the CDC plan was doomed to fail from the beginning because there was no plan for widespread testing. Instead, the CDC policy was, we are the monopoly supplier of tests and testing. Only we can do it. So right at the beginning, they say, only we can run SARS-CoV-2 tests. Only the CDC can do it. They refuse to supply private labs with samples of the virus so those private labs could develop their own tests. They say, that's not our job. Helping out the private labs, that's not our job. They can go find the virus themselves. Not up to us. Moreover, unbelievably, the CDC says we own the rights to this test, and anybody else who wants to use it has to follow our intellectual property, has to give regard to our intellectual property, and they engage in weeks of negotiation, lawyers and contracts and so forth. Unbelievable. But that was their policy. We're the monopoly supplier. The FDA. The FDA also made mistakes. They did some good things we'll talk about, but the FDA also made mistakes, and these were particularly consequential in the first weeks of the crisis. So ordinarily, laboratory-developed tests are not FDA regulated. Okay? So the type of tests which are developed by big labs, you go to your doctor and the doctor says, okay, we're going to do this test, farm it out to a big lab. They're not FDA regulated. Okay? They're regulated in other ways, but not by the FDA. So it is totally ordinary. It is totally routine for a lab to develop a new test without having to seek FDA approval for that. The FDA, in recent years, however, has trying to be claiming that they have this authority, but it's never really been exercised. Okay? Now, Paul Clement and Lawrence Tribe wrote an article about this in 2015. Now, Lawrence Tribe, if you don't know, is one of the leading constitutional scholars in the United States, particularly on the liberal side, very well respected. Paul Clement was the Attorney General under the first George Bush, also a very well respected legal scholar, okay? So they write this article, and they argue that the FDA's assertion of authority over laboratory-developed testing services is clearly foreclosed by the FDA's own authorizing statute and by the broader statutory context. Moreover, the FDA, however, uses the emergency. They use this emergency to claim now this new authority. And they say any SARS-CoV-2 test, you must get it pre-approved by us. And there's all kinds of insane stuff, like you have to fax them, you got to send them stuff in the mail and like a CD. It's completely insane, okay? It's completely insane. In fact, what they do is they invert the logic of emergency. Because in an emergency, you want to lift regulations. You want to move faster. And instead of doing that, the FDA imposes new regulations. You never had to get authority before. Now, in emergency, suddenly you do. What is extremely telling is that Clement and Tribe, here's what they said. This is 2015. Okay, here's what they said. They warn, the FDA approval process is protracted and not designed for the rapid clearance of tests. Many clinical laboratories track world trends regarding infectious diseases, ranging from SARS to H1N1 and avian influenza. In these fast-moving, life-or-death situations, awaiting the development of manufactured test kits and the completion of FDA's clearance procedures could entail potentially catastrophic delays with disastrous consequences for patient care. And that is exactly what happened. That is exactly what happened. That's what I call the original sin of the pandemic, was the failure to get testing up and running. Now, each of these errors, in some sense, was small, but in the context of an exponentially growing virus, they were deadly. And this is not simply hindsight bias. This is not simply hindsight bias. South Korea and Germany, for example, were producing hundreds of thousands of test kits, okay, in early February, even as the CDC struggled to produce hundreds of tests, not even kits, a day. So the South Koreans, what did they do? So the South Koreans, the government called in all of the potential manufacturers of test kits in South Korea. And they said, we're going to meet at the railway station in Seoul. We don't even have time to get a hotel. We're just going to find a room at the railway station. So they get all of the test manufacturers in South Korea in this room at the railway station, and they say, start producing tests now. Don't worry about approval, we'll approve them later. Start producing them now. And by the way, here's access to a bunch of patients so you can test your kits. And here's samples of the virus so you can run it with these samples. And we're going to buy lots of these test kits too. So don't worry about making a profit. We're going to make sure that we buy lots of these kits. That's what the South Koreans did. And it was the CDC and the FDA's failure to ramp up testing. This meant that by the time that testing did get going in late March, contact tracing and suppression of the virus was no longer a viable strategy because the virus was everywhere. The virus is everywhere. So that is the very depressing original sin of the pandemic, those first early weeks. So that we don't get too depressed, I want to turn now to something which we did much, much better, something which we did do right, okay? And that was Operation Warp Speed. Okay? What was the idea here? Well, the idea was this. You see, ordinarily, a vaccine manufacturer, they're not going to be willing to build a factory to produce the vaccine until after the vaccine is being scientifically tested and approved. And then they'll start building in factory, right? They're not going to take that risk. This means that it can take years. It can take years to produce a new vaccine, scientifically difficult. And then you got to build the factory, and that takes time, and so forth. Okay? What Operation Warp Speed did was several things. It guaranteed sales for approved vaccines. So the companies knew if we get a vaccine approved, we're going to sell. And that was important because there was no guarantee that the virus wouldn't go away. So if you wanted people to invest, you had to tell them, look, there's a light at the end of the tunnel. We're going to buy lots of these, even if the virus goes away, which had happened in the past, like with Zika. Okay? So it guaranteed approved sales. It paid the firms to run clinical trials, which are extremely expensive. The government paid for that. It got FDA approval to run the trials concurrently, so much more quickly. You could start your phase 2 trial before, you could start your phase 3 trial before your phase 2 trial was completed, for example. And it paid firms to start building the factories now. So the firms were building the factories to produce the vaccine even before they knew whether the vaccine was going to be successful. So that was incredibly important because it meant that the moment a vaccine was approved, the factory was up and running and ready to go. And Operation Warp Speed, this was proposed by Robert Kadlec and Peter Marks. They brought it to Alex Azar at Health and Human Services. It was supported by Jared Kushner. It was authorized by President Trump. It was led by Moncef Slaoui, who is a pharma executive with expertise in vaccines, and by Gustav Perna, a general with expertise in logistics. And I go out of my way to mention these names because I think these people have not gotten enough credit. They deserve a lot of credit and a lot of thanks for Operation Warp Speed. The ideas behind Operation Warp Speed did not come out of a vacuum. There was an academic research and practice which led to this. So most notably, Michael Creamer and Rachel Glenister had written this book in 2004, Strong Medicine, advocating for advanced market commitments. Okay? And not only had they put this idea out in the public debate, along with Bill Gates and governments, they had actually gotten vaccine manufacturers to produce 3 new vaccines for the pneumococcus virus. They had vaccinated millions of children with these vaccines and saved 700,000 lives, an estimated 700,000 lives. So Michael Creamer won the Nobel Prize in economics for multiple things, but saving 700,000 lives, that's a pretty good start. Okay? In addition, the Council of Economic Advisors, this is not widely known, but in 2019, before the pandemic, they had actually written a report showing how costly a pandemic could be to the US economy. So they were well prepared to advise President Trump. Also, on the Council of Economic Advisors was Thomas Philipson and Eric's son. Thomas Philipson was the head of the council, and along with Eric's son, he had written quite a bit on the cost of FDA delay, how FDA delay can kill people, can cost lives. This is a literature. He was coming from University of Chicago, famous papers by Sam Peltzman. Some of my work has also been in this area. And this, in fact, is where I came into the picture because I was asked to give a talk to the Domestic Policy Council of the US White House. This is early in the pandemic. Okay? To talk to them about using incentives to accelerate vaccine production. So I get on the call, and like Kadlec and all these guys, they're all CC'd. Okay, I don't know who exactly was on the call, but this was all going on at this time. And it turns out that they have invited me and Michael Creamer, who is like Nobel Prize winning world #1 expert on precisely this question. So I am very forthright, and I'm saying, look, you got to do this, you got to do this, you got to do human challenge trials. I'm pushing all this stuff. I tell them, look, I'm sort of known as like a free market, kind of conservative economist. I tell them, I've never said these words in my life before, but now is the time to throw money at the problem. Okay? And Michael Kremer it turns out to be totally in agreement. Okay? Even like on the radical human challenge trials, things like that, he's in complete agreement, which is good because he's got the authority and the gravitas. He's not quite as, he's a little bit more reserved than me, but that was very good. So after we have this, after I give these talks and Michael Kremer talks, they ask us to write a report. The White House asks us to write a report. And Michael Kremer gets many of his famous economist friends involved. People like Susan Athey and Chris Snyder and Juan Camilo Castillo, who's a very, very sharp young economist. Brings them all together and we write this report, okay? First for the US government and then for the British government. Then we become advisors to the World Bank and to COVAX. And so this is sort of the last 2 years of my life. But the first thing we do is we write this report. And what's the upshot? So the upshot of the report is simply this. We say that we can plausibly advance a vaccine by 3 to 6 months by spending $100 to $200 billion, saving $1 trillion or more. Okay, saving $1 trillion or more. And actually, you don't need a Nobel Prize for this. Kramer's amazing, but you don't need a Nobel Prize because you can see this. You can see this in market prices. Because every time there's a little bit of good vaccine news, the entire stock market jumps up. Not just the stock of Moderna and Pfizer, the vaccine manufacturers. The airline stocks jump up. The restaurant stocks jump up. The auto manufacturing stocks jump up. So the entire economy, market prices, the stock market, is telling you that the entire economy is dependent on getting this one sector, the vaccine sector, moving. Okay? So it tells you this is worthwhile to spend on this. Okay? Billions are a lot less than trillions. Billions are a lot less than trillions. And so we write this, we write in the report, in the New York Times, in the race for a coronavirus vaccine, we must go big, really, really big. Okay? So that's sort of the bottom line, but I want to tell you a little bit more about the details. You don't just want to say, well, spend a lot of money. You got to give them more, right? How? You know, where, when, exactly how do you spend this money? On what? Okay? So here's kind of what we did, kind of a brief overview. You have to ask yourself, like, if one vaccine is good, how much better is 2, okay, or 3, right? So with each vaccine candidate that you back, okay, so there's a bunch of candidates. You have the mRNA candidates and adenos viral vector candidates and traditional vaccines and so forth. With each one of these candidates that you back, your probability of at least one of them working, of one of them being successful and capable of being scaled out, your probability is going up, but at a diminishing rate. Okay? The first one is really valuable. The second one adds to your portfolio, but the benefit you get is diminishing. Right? And then you have to ask, well, we want to build a factory for each one of these candidates so that it's ready to go the moment, if it is approved, we're ready to start producing. The moment one of them actually worked. You don't know if it's going to work, but you want it to be ready to go. So how much capacity do you want? 100 million shots a month, 200 million, 300 million more. How do you tell? Okay? I mean, capacity is good because the more capacity that you have, the faster you can vaccinate the population. But it also has diminishing returns. So suppose that you have a factory which is capable of producing 100 million doses per month. Then you could vaccinate 1.2 billion people in 12 months. If you double your capacity to 200, then you could vaccinate 1.2 billion people in 6 months. If you double again to 400, again doubling your costs, you can now vaccinate those people in 3 months. But notice that your first doubling took you from 12 down to 6. Your second doubling only takes you from 6 down to 3. So the additional time that you're getting is diminishing. So you have a diminishing amount. Plus, you're probably going to vaccinate the people who need it the most first, so you also have diminishing returns. Okay. So the idea is to kind of balance off these, to build a model to balance off these kind of two diminishing returns and figure out what the optimum is. Okay. So you also want to be pretty specific. Not just say, well, the optimum is where the two curves meet. Like, demand, supply. Well, there's the optimum. Okay? So you want to have some real data. So what we did is we gathered data on over 100 of the vaccine candidates at the time, and we tried to put probabilities on them. What's the probability that this particular vaccine is going to be successful, meaning not just scientifically successful, but capable of being scaled out? And this is hard because we're not experts on this, but we look at the historical literature, we gather data, and we talk to a whole bunch of people in the industry. And it's interesting because you go to them and you ask them something like, well, what's the probability that this vaccine could be produced within a year? And they tell you, oh, it's 0. No possibility. Never happened before. That's not possible. It can't happen. But we're like economists, right? Okay, so we go back to them and say, well, wait a second. Suppose we gave you $1 billion. Would it be possible then? And they say, oh. Nobody's ever given us $1 billion before. Yeah, I mean, if we had that kind of money, we could do this and this and this, and they start thinking about it, and you're able to kind of get some probabilities, right? But this was the thing. This is totally unprecedented to spend this kind of money. So no one really knew, right? So we try and put probabilities on each of these. We then combine that with the data on COVID mortality rates for every country in the world, the age population, the demographics, distributions, and so forth. And we kind of calculate what's the optimum portfolio to have. Okay. And we get something like this, something like 18 candidates with a capacity of 300 million vaccines a month. Okay. And it varies depending upon your characteristics, but this is actually pretty robust. You really do want to go big. You really do want to go big. Okay. Going smaller can cost you quite a bit. You lose quite a bit. Going bigger, you don't lose that much. So this is kind of a pretty robust number. What we also realize in doing this, and this was difficult to explain, but you didn't want to buy doses. You wanted to buy capacity. Okay? This is important because if you just go to a company and you say, I want 100 million doses, well, then they could produce a small factory and just kind of, dole it out over time. And that's not what you want. So you want like 100 million doses fast. But then you have to write that into the contract and what penalties are going to happen, what penalties will happen if the company doesn't make the date, things like that. It becomes very, very complicated, very difficult to do, and also very expensive. So what we suggested, you wanted a lot of push funding. You wanted to support building of the factories, running of the clinical trials, not just pull funding, which is offering a high price. So we advise governments along these lines as best we can. All right, so what happened? What happened? Well, the bad news is that the world did not go as big as we wanted. Okay? Operation Warp Speed, the US response, was by far the best. Operation Warp Speed spent about $15 billion. The UK and Europe spent maybe another $1 or $2 billion on advanced market commitments and these kinds of things. Okay? The rest of the world spent next to nothing. So the world did not go as big. We wanted 100 to 200 billion. The good news is that what we did was very, very valuable. What we did was actually incredibly valuable. So we estimate, this is a paper in Science, that If we get 3 billion courses, 6 billion doses in 2021, I think we're going to get actually a little bit more, but this was at the time. That was worth $17.4 trillion to the world. So if Operation Warp Speed and the similar programs advanced the capacity by, let's say, 1 billion doses, billion courses, okay, that was worth on the order of $2.4 trillion. So in my view, Operation Warp Speed had by far the highest benefit to cost ratio of maybe any government program, ever. Maybe Manhattan Project is a competitor, winning World War II is a competitor, but it had an extremely high benefit to cost ratio. We should have gone bigger. We didn't, but what we did do was very, very valuable. Okay. That's the good news. That was the good news. We're now back to failures. There are a lot of things which we could have done but didn't do. We could have done an Operation Warp Speed for masks and tests. Okay? We could have given early vaccines to nursing homes. We could have studied the virus more, experimented more. We could have done human challenge trials. First doses first, I was a big proponent of this. Fractional dosing, rapid antigen tests, there are a lot of things we could have done. I'm not going to talk about all of these today. I talked about all of them throughout the pandemic. I'm going to say a few words about the first 4 of these, okay? Things which we could have done but really didn't do. Operation Warp Speed for masks and tests. I want to take you to an incredible email discussion early in the pandemic between Mike Bowen, who is an executive at Prestige Ameritech. This is the last producer of N95 masks in the United States. And he emails Rick Bright at BARDA. Okay. January 22nd, this is what he says. We have 4 N95 manufacturing lines that aren't in use. Reactivating these machines would be very difficult and very expensive, but could be done with government help. January 25th. We're getting lots of requests for masks from China and Hong Kong. If China stops sending us masks, American hospitals could run out. This is January 25th, so people knew. People knew. January 27th, Rick, I think we're in deep shit, the world. Now, Operation Warp Speed followed what I call the American model. Okay, what do I mean by the American model? The American model is using the federal government to amplify the power of America's incredibly large and ingenious and powerful private sector. Not to command and control and to rule, but to amplify. The American model is to join the visible hand and the invisible hand, to get them working in the same direction. That's what we did with Operation Warp Speed. We got private industry and the federal government working together in the same direction. We could have done the same thing for masks, as you can see. We didn't do it. We could have done the same thing for tests, like rapid antigen tests. We didn't do it. And the reason, I think, is there was never, shockingly, there was never an understanding in the American government of the American model. So we got Operation Warp Speed almost by accident. You know, Cadleck, kind of a military guy, he was a pro-action guy. You know, we did something similar actually for nasal swabs. So like, for random kind of reasons, in some cases we did this, in some cases we didn't. There was no general big picture perspective on how the US should respond to a crisis and what the American model really means and how it works. We could have, and I believe should have, issued the vaccines to the nursing homes earlier, perhaps even before all of the clinical trials were done. Okay, that's my view. the nursing homes were really the epicenter of the pandemic, okay? Nearly 1/3 of all the deaths up to January of 2021, when the vaccine started to come in, were in the nursing homes. So the nursing homes were really by far the worst hit, the single place which was the worst hit. And if we had had vaccines, co-author and I calculate, if we had had vaccines out just 5 weeks earlier, if we'd start vaccinating the nursing homes just 5 weeks earlier, a little bit before the massive run-up in deaths in November and December, we could have saved 14,000 lives. 10 weeks earlier, we could have saved 41,000 lives. And we had the vaccine to do it. There's not that many people actually in the nursing homes. There's like 1 million people at any one time. So we had enough vaccine to do it, but we didn't have the courage to do so. I think earlier distribution would also have helped to iron out some of the kinks in the distribution system. Because amazingly, even though they were told time and time again, the vaccines are coming, the vaccines are coming, the state and local governments, as you may recall, they were not prepared. They were not prepared for the rollout. It took them weeks to really get the rollout going. So practicing a little bit earlier. I'll take questions at the end. Studying the virus. This is an amazing story, an amazing story. So FAST Grants, which was formed by my colleague and friend Tyler Cowan and the entrepreneur Patrick Collison, okay, they raised over $60 million in funding. They raised the money in funding, and they spent it before the NIH had reviewed a single new COVID grant. Incredible. And it wasn't just the government. It wasn't just the government which was slow. So Saliva Direct, which is a highly successful spit test, okay, from Yale. It was used by the NBA, and then it was used widely throughout the country. Would not have been successful without FAST Grants. Okay? This is Professor Annie Wiley at the Yale School of Public Health. And she said, we couldn't have done it. We could not have done it without FAST Grants. Now, just think about this for a second. Professor Annie Wiley, who was at the Yale School of Public Health, she could not get funding from the Yale School of Public Health in time. What? The Yale School of Public Health. There's a pandemic going on. Thousands of people are dying every day. They don't have funding? That's insane. That's crazy. Instead of getting funding from the Yale School of Public Health, they have to go to my friend who works down the hall from me. That's crazy. Can I say, like, I'm really happy that Batman is protecting Gotham, but what happened to the Gotham Police Department? That's a bad sign. That's a bad sign. And the fact that we're relying on my friend down the hall to fund COVID research during a pandemic is crazy. But that tells you how deep the rot is. It's not just government, the rot is deep. And if I haven't blown your minds yet, okay, think about this. Yale University Endowment posts returns of 40%. The $42.3 billion endowment. Yale is sitting on $42.3 billion. They could not get funding to one of their own researchers. Instead, it has to come from my friend, Tyler Cowan and Patrick Collison. Unbelievable. Human challenge trials. So, January 11th, 2020. Okay? This is when the genetic code of SARS-CoV-2 from Yang Zhenzang's lab in China is uploaded to the internet. And within a matter of days, Barney Graham at the NIH and Wang and McClellan, okay, have developed what will become Moderna's vaccine. Okay? So by January 13th, they have designed a vaccine. Almost everything else was testing. Okay? Almost everything else is testing. Because here's the problem. Standard field trials, they're very, very expensive, and they take a long time. So here's how a standard randomized controlled trial works. You take 30,000 people, 15,000 of them you give the vaccine, 15,000 of them you give a placebo, and then you tell them all, go live your lives. And you wait. And you wait. And you wait until enough of them have developed COVID from their ordinary life activities that you can say, aha, there was a statistically significant difference. More people got COVID in the placebo group than in the vaccine group. But it takes time. It takes time. A human challenge trial works very differently. So in a human challenge trial, you take 100 volunteers. 50 of them you give the vaccine, 50 of them you give the placebo, and then you expose them all to the virus. Okay, you expose them all to the virus. And the virus only takes a couple of days to settle in. So with a human challenge trial, you could know within a week whether your vaccine is working. And we didn't do this. Not until very late. British did one very, very late. The National Institute of Allergy and Infectious Diseases, they rejected human challenge trials. So Anthony Fauci, Dr. Fauci's is New York Times, Dr. Fauci's office said the Institute had no plans to fund COVID-19 human challenge trials in the future. Many bioethicists support that decision. We don't ask people to sacrifice themselves for the good of society, said Jeffrey Kahn, director of the Johns Hopkins Berman Institute of Bioethics. What? We don't ask people to sacrifice themselves for the good of society? What is he talking about? What are police officers doing? What is the military doing? What do coal miners do? We ask people to do this all the time, right? Here's Chip off the old block. This is Maxwell Tabarrok, tweeted, bioethicist. We don't ask people to sacrifice themselves for the good of society. Also bioethicist. Stay at home and wear a mask everywhere for the next 2 years for the good of society. Right? I guarantee you, this guy Jeffrey Kahn, I guarantee you, he's not saying we shouldn't have, vaccine mandates for kids. No polio vaccine mandate. He's not saying that. So what on earth is he talking about? It's crazy. Right? I think what he's talking about is this. This is something which I found in talking with a lot of people during the whole pandemic. What I call the omission-commission fallacy, or status quo bias. And this is a fallacy or a poor way of thinking, I think, which is held by both the public and by experts about a lot of things. Here traditionally is one sort of traditional story about vaccines. Why are people sometimes vaccine hesitant? Well, one reason is that they think the following way. Suppose they're thinking about whether they should get their child vaccinated. Okay? Well, they think, well, if I have my child vaccinated and the child gets a rare condition because of the vaccine, which sometimes happens. Okay? It's rare, but sometimes happens. Okay? Then it will have been my fault. I will have done something that harmed my child. I will regret that. I will feel bad about it. It will be my fault. But implicitly, if I don't get the child vaccinated and then the child gets the disease, well, that was nature, that was bad luck, that was ill fortune. It wasn't something which I did to them. Nature did it, bad luck did it, but I didn't do it. Okay? And people think this way about people. I think this is why, that's how the public thinks sometimes. But why don't these bioethicists like human challenge trials? Because in a human challenge trial, the people running the trial have to infect people. So they don't want to be the ones who do it. They don't want to be the ones who infect somebody. God forbid they get sick, maybe even die, it's a possibility. And they don't want to be responsible for that. Even though more people in a randomized controlled trial, in a field trial, might actually end up getting COVID among that 15,000 placebo group. More people there may actually end up getting sick than in a human challenge trial, but it wasn't us. We didn't do it. And to which my response to this, both to the parents and to people, the bioethicists and to Fauci and people like that who didn't want to do this, is it's not about you. It's not about you. It's not about that you're going to feel regret. It's not about that you're going to feel bad because you did something and somebody got sick. Do the thing which increases expected value. Take your own feelings and emotions out of it. Do the thing which is best for your child. Okay? Do the thing which is best for your child. Calculate the expected value. What's better, the rare side effect or getting immunity from the disease? Do the thing which is best for your child. Or in the case of the National Institute, do the thing which is best for society. Not, oh, well, if I do this, I'm going to feel bad. It's not about you. Take your feelings, take your emotions out of the situation. Do the thing which is best for society. Okay, so let me conclude. So, as an economist, I think that some of the economic way of thinking turned out really to be really very useful in a pandemic. In this context, by the economic way of thinking, I'm thinking about numeracy, thinking as a utilitarian, thinking as a Bayesian, statistically, and so forth. And it wasn't complicated stuff. It was just ways of thinking. So use numbers. Billions less than trillions. Like putting numbers on this stuff that actually helped. I mean, it sounds incredible, but once we did that, politicians and people could understand that better. This really was sort of revealing. Billions or less than trillions. Understanding exponentials, right? This is something which economists are good at, that growth rates. How if you don't stop a virus at the beginning, because of this exponential growth, it becomes just much harder to stop it later on. Okay? So understanding exponential growth. Understanding externalities. So not just the externality of, if I get the disease, I may spread it. If I'm vaccinated, I may be less likely to spread it, things like that. But in this particular case, there was a tremendous externality in that the entire economy was dependent upon this one sector, the vaccine sector. So understanding the supply chain, this tremendous externality, was very, very important. Understanding opportunity cost, classic economic idea. I say that the FDA, more generally, not just during COVID, but the FDA can commit two types of error, right? They can allow a bad drug onto the market. And the thing about that error is that it becomes public. A bad drug is allowed on the market, people get sick, heads roll, the FDA is blamed, there's hearings in Congress, people are upset because they know that their husband or their child took this drug and they got this side effect and they were injured and they know it and they complain. It's a very visible error. The second type of error which the FDA can make is by failing to approve a good drug or delaying a good drug. This also kills people. But the people who die, the people who would have lived had this drug or vaccine been available sooner, nobody knows who they are. Okay, we know they're there statistically, but they're not individually identifiable. So the people who die when the FDA fails to approve a good drug or delays a good drug, they're buried in what I call the invisible graveyard. And economists are pretty good at looking at the invisible hand, at seeing the invisible hand. We're also pretty good at seeing the invisible graveyard. It's important. Avoiding status quo bias and the omission-commission errors I talked about. Being utilitarian, thinking about costs and benefits. Doing the thing which increases expected value. So my conclusion is that the numerate, utilitarian, Bayesian way of thinking can be very valuable. I hope we don't have another crisis to test this, but we probably will. So thank you very much.